Okay, welcome back. This is Chapter 1. If you guys remember from the week 0, we start every one of these chapters with going to the weekly task list and going to the particular week that we're in, and then you do whatever it is that I tell you to do. Read the chapter, watch the videos, take the syllabus exam, blah, 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 blah. Answer 4 questions in your journal. Okay, so the way this is going to work is I'm going to just go through the book. I'm not using PowerPoint slides, so you should have the book handy and basically follow along. That's essentially what we're after here. Okay, so let's begin. So the book is basically set up in 4 sections per se. The first section is kind of introductory. That's what we're going to be doing today. They have a kind of a technology section. That's chapters 2 through 11. And that's where we go over the OSI model. And trust me, you're going to hear that phrase, the 7 layers of the OSI model, so many times you're going to be mumbling that in your sleep. So just be prepared. That's going to want to be one of those things that you're going to have to know. After that, they talk about infrastructure issues. Chapters 12 and 13, and then last chapter 14 is basically kind of management issues and, what is it you need to do to be able to manage a network. So chapter 1 starts on page 1. Woohoo! And they talk about the learning objectives, and I think the learning objectives are actually pretty cool. It talks about, the learning objectives in general for each of these chapters is, why should I bother to do this, right? Why should I bother to learn this chapter? So here's their answer. Why computer networks are important, why data is sent as packets, and why is it important to deliver the packets, blah, 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 and the standard technologies to accomplish these tasks. That's what this chapter is all about. We're going to get into a lot of weeds a little later, so let's just continue. Okay, they got some definitions, and I'm not really too obsessive when it comes to definitions, so let's just kind of go through it. They talk about what the heck is data communications? And so their definition is not bad. It talks about the movement of information from one computer app to another, to an application on another computer. Yeah, okay, that's not half bad. And then they go on to say that the transmission system that enables networking is called a data network. Yeah, okay, cool. Well, let's continue. They talk about on page 2, they talk about some examples you're probably likely to have in your home of a network. This kind of sort of resembles what I have. In my house, I have a home network. I've got a few machines that are hardwired in. I have a few machines that go on Wi-Fi. I'm connected to a cable modem system that goes to my internet service provider in the sky somewhere. Using coax cable for the first a couple hundred feet, and then it switches over to fiber optic cable, and then God only knows what's going on up here, and then finally gets down until I get to the campus network, and so I'm going to the campus network reading off of a web server. So that's kind of a good example of 3 different networks at play: the network inside my house, the network at the university where Blackboard is, and then the big network in the sky, which we don't actually really directly play with, but we definitely use it. Okay. So let's drill down a little bit more. So the computer, perhaps you have a card in your computer. It's not likely. Those are kind of passé. But on the motherboard of your tablet, on your PC, is probably either an Ethernet port or a wireless. More than likely, it's all wireless now. And all these components, the individual components inside the computer plus all the stuff inside is part of that network. Cool. They talk about that there's actually a phone network that goes on top of this, but it's not really covered in the book. Well, it actually is a separate chapter that we're not going to get to. But if you have the printed copy of the book, it's not in the book at all. Okay, so let's continue on. They talk about a common set of technologies that, when I'm working on these things, I have to have the same thing that everyone else's has. If I'm working on a web server, I have to have a browser that's compatible with the web server. So, web and email and video and music, all those kinds of things use a common set of technologies. In the old days, you could say, well, I'm using this kind of network and I'm using this kind of network and we're not going to talk. That was one way of doing things. Thankfully, that didn't last very long. And now practically everyone is using standards-based. So everyone is on the same sheet of music and everyone has an opportunity to listen to music or see a video. For example, this video now being posted on YouTube, it's available in like 4 or 5 different formats so that any device can view this video. You could be on an iPad or a phone or a full honest-to-God computer or tablet, whatever. And the system basically looks at what you have and says, aha, I see you're compatible with this, this, and this, and so I'm going to send you this video feed in this particular format. And so it's all just about playing by the rules. Okay. On page 3, they go into, why do we learn this? And there's a lot of good information here. They'll talk about, networks are one of the most essential components of a computer system nowadays. It used to be everything was like data centric, in the mainframe days, the data was the most important thing that the company had. And yeah, that might be the most important possession, but believe it or not, if the network went down, it wouldn't matter if the data was good or not, you won't be able to get to it. So it's sort of like the network is still probably one of the most important components into a business's IT infrastructure. There are obviously economic reasons. Again, if my network goes down, I can't switch over to a phone operator and take my orders anymore. I mean, those days are gone. So if Amazon goes down, you're not going to call them on the phone and say, oh, I just found these new pair of shoes, I'd like to place an order. And that's not the way it works. Economic could be from your perspective as well. I mean, I know people who, if you combine your wireless bill plus your ISP bill at your home, it's probably around $200 to $300 a month. Yeah. If you combine those together, that's what it costs you as an individual to get connected to the internet. Yeah. So we got that looks like big business to me, doesn't it? Okay. Security issues. In the old days, again, I had my own little network inside my building. I wasn't connected to the internet, and I didn't have to worry about people coming in and breaking into my system. Now that is a big, big business. Everyone's heard of those goofy stories where, some vendor somewhere has a break-in and they steal all these credit card informations and blah, blah, blah. That's probably, most likely, a failure of their network that allowed this to occur. They talk about the growth. On page 5, they talk about how much the internet is growing. And if you take a fixed internet, meaning like internet service provider to your home, that's still a healthy increase. But mobile, wow, 57% increase in mobile data. Yeah, that's big business. So, is it the businesses that are doing it? Maybe. The consumers? Yeah. And we got there first, okay? So our growth in North America is actually kind of slow. But if you talk about, Asia and Pacific Rim, they're kind of late to the game, and so their growth is a little bit higher. Not that that really matters. But anyway, the bottom line is that wherever the population centers are, that's where we're going to get an awful lot of this stuff. So this is big business. Yeah. So if you want to be in this business, think about it from another perspective. They talk about one of the little factoids in the book there. They talk about that this shows about 23% growth in internet use as an industry. Now, how many industries can say, oh yeah, we have 23% growth? I mean, there are companies out there would kill for double-digit growth in sales. I mean, so yeah, this is kind of important stuff. Okay. Then they talk about careers, which is kind of sort of the same thing as what I was talking about, how important all this is. You could be part of that. Network administrators, from looking at the Department of Labor kind of stuff, the network administrators' jobs are one of the highest paid. That and database administrators, the two of those are pretty up there. starting salary is about $72,000 a year. That's not shabby. And about 12% growth rate per year for, new applicants coming in. Again, that's not bad. If you wanted to be in the business, that'd probably be the way to go. They kind of talk about a history lesson on page 6. They talk about the technology milestones, those things that occurred that allow us to get to wherever the heck we are now. And so they talk about essentially 4 technologies. We're going to go through them one at a time. The first one is the telegraph. Everyone kind of knows what the telegraph. You've probably seen, goofy movies where they've sent messages by telegraph. Multiplexing, and we'll describe what all this is. Switching, and then packetization. That's almost a made-up word. Basically making a verb out of making packets. Packetization. Oh well. So, page 7, they talk about that, the telegraph, patented in 1840. The first actual use was a few years after that, 1847, I believe. Anyway, it was very simple. It took some wires, and basically you had a battery over here, and you hit the little button, and it sent a signal to the other end, and a receiver picked it up and made a clicking noise. Kind of sort of simple. But this is the basis of all modern technology for communicating today. I mean, this is the foundation. This is how everything works. It's just slightly different technologies. Okay, so there were 2 major foundations that occurred doing this. One is that data was sent along wires. Okay, all right. And that the sender varied a signal on the wire. In other words, he varied the voltage. In this case, the voltage was either on or off. So, if you were using a 12-volt battery, you either had 0 volts or 12 volts. Kind of simple. Again, that signaling isn't very impressive, but it does work. And the second one was encoding. So one is you had to impress a signal upon a wire. That was a fundamental thing. And the second is you had to somehow encode your message, because English text doesn't sound like clicks. So you had to create something, and everyone's heard of Morse code, yes. There's a cool little thing you can do here if you wanted to kind of goof off. There's a website you can go to. It's in the book there, and it's called Telehack. So. And Telehack is one of those goofy little things. If I go in here and I say Morse, then I can type in a message like, "Hello there," and hit the button, and boom, that's what Morse code looks like. I will tell you that the Morse code basically doesn't really have upper and lowercase letters at this point. So their encoding was incredibly simple. And 26 letters plus a few little symbols, but not much. So essentially letters and spaces, and that's about all there is. Okay, so that's Morse code. Another competing technology that we use today, we don't obviously use Morse code now, but there's a thing called ASCII, and we'll get into a little bit more about what that means in just a minute. So I'm going to go over to an ASCII guy. So let's see. www.branna.com. Whoop, I didn't spell that right. Let's try that. Oh man. Branna.com. Okay, cool. Anyway, and it's kind of like a language thing. So if I go to Branna ASCII converter, I can type in "Hello World," and what you see is what that encoding looks like in hexadecimal or decimal or binary or all the rest of this stuff. Okay, so that was the key. The takeaway was it converted things into a different type of a signal, something that the signal could deal with. Okay, we've reached the 15-minute mark, so we'll continue this discussion in just a few.